Kia ora mai tātou. Te nuinga o ko te mohio mai nei ki au, no Ngāti Porou tēnei, no te whānau a Pōkai, no te kapahine kōpeka, ko pōhautia, rāwa ko hekurangi o ku maunga. Nō reira, tēnā tātou katoa. E mehana mai e a Brazil, parihia, ko te pō tēnei wā. So I'm greeting you from Brazil. It's nighttime here. So good evening, everyone. That was just my Skype bit. I'll shut up about that from now on and hand over to Cooper. Cooper. Moko, you've got many names tonight. You're Moko and Mako and Cooper. I'll hand over to Moko.
I got that one wrong.
Kei te pai.
Tēnā tātou, no Ngāti Raukua, no Waikato, no Ngāti Rangiti ahau. Kei ōtaki ahau e noho ana, he kaiako ahau ki te kura ā-Iwi o whakatupuranga Ruamano. Kaiako Pāngarau, kaiako Hangarau Matihiko. Kua rua te tau ahau e whakaako ana i te Pāngarau ki te taha Wharekura. He ringa raweke ahau. Nā reira, ka tutu haere au me ngā mea katoa, koenei pēr te take kei te pēnei. Hau i tēnei wā, kia ruku hohonu ki ngā āhuatanga o te Pāngarau, hei pānga mō aku āpona ki taku kura. Kia ora, you might hear some stuff in the background. My baby's just had a shower and her mum's just changing her. But yeah, I'm from Otaki. I've been teaching Pāngarau for the last 20 years at our Kura. I've taught NCEA Pāngarau for the last 20 years. The past couple of years, my life's become way busier. We had my first child 7 years ago, and then another baby last year. So, and then all the other mahi that I've been doing with Pania and Tony. I was a part of the writing group for the new NCEA standards for Pāngarau. And then I've been on Pania's team for the new Maro. But yeah, I'll pass it back to Pania. Tēnā tātou.
So if I say that I was actually Moko's teacher a while back, then you can do some maths on that sort of, you know, how you guess people's ages. So I think I might have actually taught you the maths as well. But no, it comes from his whānau, that maths buzz. So we've talked for a while, Moko and I, about how maths is not Pāngarau, and neither is Pāngarau mathematics. But what we've done in our kura and in our time teaching is that we've worked in a space where Pāngarau has mathematics in it. So even given the times that we're in now, I think it's important to carry on looking at how our mokopuna, our future mathematicians, people, humans, are able to use maths in their lives, to enjoy maths in their lives, and have a relationship that's worth having with mathematics, rather than the old, I hate it, yeah, get it away sort of thing. So that's been my life's passion since I left teaching. Can you go to the next slide, please, Moko? All right, so you've all probably seen that abstract, and we'll go to the next slide. If you haven't, I think it'll be in your paperwork. When we first started looking at changing the marautanga, it became called Te Tīrewa Maro. So it became a part of a whole group of areas for learning that you combine and work together. And we based what we started with completely on the akamatua, because the whakatauki in the maths, the Pāngarau marautanga was kia mau ki te akamatua, kaua ki te akataiapa. And it basically means grab hold of those things that will hold you steadfast, that have specific rules. that have specific ways of being, doing and knowing. And so we thought that we should bring that whakatauki back to life. And the group that has been leading the curriculum change, the marotanga change, wanted very much to not base the marotanga on the strands of mathematics. I'll explain that as we go through, but to base the strands on who our mokopuna are and who we want them to be. So they created our 4 main headings. They created uri whakaheke. So our mokopuna are descendants. They're descendants of our tipuna. And we see them as the living face of those tipuna. So who do we want them to be in the future? He puna kōrero is, actually I'll go around to tangata. He tangata is, so as well as being uri whakaheke, they have their own, themselves in their own right, who they will be and how they will be, guided by their tipuna. The puna kōrero is that they are speakers who are able to communicate no matter what. And if you bring it into the Pāngarau space, that means they're able to communicate through mathematics and Pāngarau, and using the words of mathematics, using the phrases, understanding them conceptually, what they mean and how they act and how they behave. And the other part is he akonga. And the akonga is the learner. And so a learner is able to also learn the content of any of the learning that they're doing. So conceptually, you've got the uri whakaheke, the tangata, the puna kōrero. The akonga is the person that learns all the things that go together. And it's the akonga always in the centre. It's not the maths. Because that was one of the other things when you say, oh, you teach maths, and we're going, no, we teach mokopuna, and they learn maths with us. So it's a really slight shift, but it's an important shift. And we wanted to make sure that that was what we had right bang in the middle. The row, the leaves coming off are then the maths whenua, but they don't come off in a specific point. They just are growing off of that akamatua, the main vine. So Moko is the artist who whipped that up in the day that we were talking about it. We didn't get to use it, but we want to make sure that people know that this was the thinking that went into it. Each of the little cells, those are the pūtoi, the cells of the vine, and they're living, have all of the different sorts of ways of being that we wanted our mokopuna to have, to be able to do Pāngarau and mathematics. That all, Moko? Did I forget anything on that akamatua? Ka pai. We'll go to the next one. And what I've thrown together here are the different ways that we can look at Pāngarau and mathematics as hoa haere. So I used to call them something, and someone said, oh, but they work together. And according to whichever kaupapa you're using, they share strengths. So some of the things that I've seen happening through Eric Goodstein, Margaret Frankenstein, critical maths educators, or Les Goss Mosley, those sort of people, is you can use maths to fix something that's going on in your community. You can use it if you're striving for social justice. You can use maths if you want to independently build something within your own kaupapa tikanga kawa mātauranga, your knowledge bases, the rules and the reasons why you're doing things. Maths can be drawn from it, and you do maths while you're doing those things. And that's one of the things probably that we've been getting wrong, is that we do these things and then we forget to identify for the mokopuna what the actual maths is that they do. So they learn. And one of the biggest examples I can use, and I use it all the time, is that you can make a picnic table. That could be your kaupapa. You need a picnic table, you're going to make it for outside the classroom. And when you ask, when I asked the student, that's great. How do you know, what's your evaluation? Knowing that you've got this, that you've done the work and the kids have understood it and they went, you've made a picnic table. But what they didn't do was say this is the mathematics that they actually used when they were making that picnic table. So that's the thing that gets left out if we're not careful. And I want to say this one, aesthetics and life enhancement. There's a maths in so many different spaces where we created things that are quite beautiful through mathematics. So we can do that. And the other thing is that I've talked about and learned about is that maths, really good maths, is elegant. I've heard people say that it has its own elegance because it's a culture on its own. It has its own language, it has its own rules, it has its own ways of being, the ways of seeing the world. Maths is an actual culture on its own. So that elegance through maths, I think that's the thing I missed out on. I think that Moko gets it. Though that's the thing that I missed out on, got really, really mad about when I found out that I don't do maths as well as I'd love to. So then there's the practical and the pragmatic. You can pass tests using maths and you can pass the assessments and you can get a good mark for your CV, and apparently that will give you the best jobs ever. And I have a wee bit of doubt about all of that, except that it is maths, we all know it has such status that it filters people out, in and out, I'll say. So it's a really good filtering tool, which is not fair on maths. Okay, so what's our next one? I won't talk too long. So what I've seen is when you distinguish the Pāngarau from the maths, you allow students, your mokopuna, to see that there are worlds that are both as important, as beautiful, as exceptional, as good as each other. Because you strip away the status that makes maths better than your own cultural knowledge. So you allow the cultural knowledge to also have status. You're then far more specific about ko tēnei te mātauranga Māori. This thing that we're learning, this is the part that is mātauranga Māori. Then when you do that, you have to also be really specific as well, okay, what's the maths? It's like the picnic table. What's the maths then? And how does it actually work? So you're being far more specific. There's too often where they're glued together. Oh, they're the same. Oh, you're doing maths, but not enough specifics on the maths or the knowledge and the thing that you're doing. Okay, next one. Okay, this was something really important to me when I was talking to a Kura about joining our TLRI, which is about going in and observing how Kura, it's a bilingual school that did this specific work and that is coming on board. And I was talking about how if you call tukutuku panels maths and you say, oh, they're doing maths when they do tukutuku panels and they always did maths, what you've just done is you've kind of wiped away the point that they were doing mātauranga Māori, our ancestors. And while people can see mathematics in it, and they can see symmetry and all sorts of things in those tukutuku panels, it was the knowledge of the elders that made those tukutuku panels. They never learned maths as a subject or as a discipline or as a way of doing and being, but they could make tukutuku panels. And then a teacher went, oh, so you just actually hidden it under the table. She sort of threw under the table the mātauranga Māori. And it was the first time I'd heard someone say that. And then she says, oh, so then you might as well just say we're going to do our symmetry boards rather than the tukutuku panel. Because if it's maths, then you're not doing tukutuku anymore. Or if it's tukutuku, you're not doing maths anymore. And it's actually okay for both of those things to exist in a space. And I think it's good for our kids to know that 2 sets of knowledge, 3, 4 sets of knowledge, more can exist in one space. And they can learn them simultaneously, knowing which each one is. Okay, Moko. And I think I'm okay. The only one other thing that I think I wanted to touch on, I'm sure this is the last one, is that You can do that kaupapa inquiry, which I can see our kura are doing, the ones that I'm working with at the moment. I think they've got to be really good inquiries. They can't just be that Joe and his 45 watermelons walking down the road and then picking up 5 more, because Joe actually can't carry those many watermelons unless they're this big. So what we've done with some of the context is really just make problem solving into a problem. The other thing that I'm really certain about, and I've enjoyed watching with young people, just little ones, is mathematical inquiry. So when they go, what's that random dot between the 8 and the 5, or 8.5, or you say, can you sort these numbers, and you ask them what they think that quantity is, and they go, oh, it's 85. Well, what's that dot in the middle? Oh, it's just a random dot. Someone put it there. So the inquiry is into what's that random dot between the 8 and the 5. That itself, for some young people, gives you that, opens it up for you to just explore decimals, the random dot. So getting kids to ask those kinds of questions and then to inquire, do more inquiry into that, it's part of their world. It's still part of their world because they ask the question, so they want to know. And those are exciting inquiries. They're as exciting as the real world, because we can see how kids can start to move into that abstract and generalizing thinking space. And you see them do it when they're really excited about maths concepts that you want to teach them. You watch them just come alive without needing to have the real world stuff. It's the equipment, it's what they're learning. You just watch them buzz when they learn something new, and it's just about the mathematics. So that sort of mathematical inquiry, I think, is hugely important as well. Ka pai moko, so have I got anything else? But here's the real stuff. And so Moko, I'm going to hand it over to Moko because he's been doing this work.
I don't know if it's the real stuff, but this at my kura in Otaki, we created a thematic integrated plan that we aligned with NCEA. It began just as a kaupapa revitalizing stream that we have on our grounds at Kura. So that started back in 2017 by one of my year 12 akonga, who was passionate in environmental revitalization. She was a filmmaker, all these types of things. And then she come to the kaiako and asked if we could do this, which we started back in 2017. And over the last 7 years, it's progressed now as our kaupapa kōkiri, which is a term that was a part of the tirawa marautanga before, has been chucked away now, but it's basically our theme at Kura. So like Pania was saying, this kaupapa, so it covers a whole lot of the NCEA standards. So building this kaupapa last year, it started off with the NCEA level 1 pilot standards for Pāngarau, the NCEA level 2 pilot Pāngarau for standards for Pāngarau. And then we seen that there is a whole lot of alignment from the other standards that helped with this kaupapa. So yeah, so that's basically what this is. There was a whole lot of mathematics also in this. That's so I teach Pāngarau. At the end of the day, I teach Pāngarau. A part of my Pāngarau, there's a part of mathematics, there's a part of tikanga Māori, there's a part of kōrero tukuiho. That's what I see Pāngarau as being. Before the last 3-4 years, I would have called myself a mathematics teacher, because that's all I taught. I just taught math skills. We tried to put something like this into play, but with the standards being the way they were, I couldn't align all of the elements into the kaupapa. So whenever I sent something to get moderated, it gets sent back to say that we hadn't covered everything, even though I know my students done a whole lot of work. So Basically, he manga tupua was the kaupapa. It has now progressed to 5 kaupapa um, that sit under it. So this is the manga. This was the manga after it was being cleaned back in 2017. The kids cleaned out the stream. They done a whole lot of riparian planting, and I forgot to take some photos of how it is now. But all the trees that are on the side there, all the flax plants, they are like 2 meters high. So it's huge. Um, and like at the start, there were no species in the stream. We've got eels and stuff in there now. There's a whole lot of bugs. There's like the stream's alive, which was our goal back then. But then what we ended up doing was creating a whole lot of other kaupapa kōkiri that fell under he manga tupua. So these are our kaupapa kōkiri at Kura. The first one was manga tupua, which is revitalizing Maringi Awai, the stream that was just on the screen. Ngā tūtohu whenua Otaki, the landmarks in Otaki. He Kura Taiao. He Kura Taiao is a program where our kids either go to the bush hunting or they go to the ocean to collect kai at the end of the day. So every Friday, a bunch of kids go to the bush or go to the ocean and do fun stuff. Kaupapa whakarauora I te taiao. So we have a kaupapa. These are our revitalization programs that we created in the last couple of years. So we have a watercress kaupapa where the akonga had to research if watercress can clean the streams, because obviously watercress, well, if you don't know, watercress does clean streams. It eats all the nitrates, it eats all the phosphates, and it cleans up a whole lot of pollution. The second kaupapa was a tuna kaupapa, which I ended up breaking up into 2 different levels. So one kaupapa was around the kids making hinaki, and obviously using measurement, the new measurement standard to align with that. And then the other kaupapa with that was my kids collecting data. So collecting data on the tuna in our streams in Otaki. If you haven't been to Otaki before, Otaki, like we have the mountains, we have rivers, we have lakes, and then we have the ocean. So it's like, it's the perfect place to live. It's the perfect tile. But like over the past 60 years, it used to be a whole lot of streams, lakes, and then the farms have taken a whole lot of things away. Next one is Kura. So Kura is a swimming program that one of our Wharekura created for her PhD, and she's come back to Kura to run that. And then the last one, Te Koha Tūrongo and Te Mauri Ha. Te Koha Tūrongo is a program where our year 13s build tiny homes. So they build tiny homes. Right now there's, I think they've started on the 7 tiny homes. And by the end of the year, the tiny homes will be finished and they get to take the tiny homes home or wherever they take them. And then Te Mauri Ha. Te Mauri Ha is it's a program where the kids created a truck, house, truck, class, shop, and that's completed now. And then next week it will get blessed, and then next term they'll have a cafe out at the beach where they are going to start selling stuff. So those are our 5 main kaupapa at Kura in our Wharekura part of Kura. And sorry, oi, puta ki waho. Sorry, ki waho. But obviously Pāngarau, there's Pāngarau in all 5 of these kaupapa. Okay, so he manga tupua. When I first sat down with my students at the start of the year, I put the kaupapa to them and I said to them, well, think about some questions. What questions do you think, what are the things you want to know? What are the things you want to know about our taio? What are the things you want to know about watercress? What are the things you want to know about hinaki, about eels? And that's where we started. So these are some of the questions that they come up with. How do I make a hinaki? Does watercress improve water qualities at streams? Do we have healthy eels living in our streams? Do eels have an impact on the health of manga? What species do we have in our manga? And what were the streams like in the old days? Why are they the way they are now? From there, um, we created some kaupapa that align to these ātai. So there's 3 pictures there. The first one, that's my students making a hinaki last week. The second one is a watercress pontoon that we planted, that we put into the stream at the back of our kura last term. And the third picture is my students measuring an eel that they caught in the hinaki. Okay, so he manga tupua hinaki. So with the hinaki kaupapa, there is an assessment for kaupaetahi for Pāngarau, where the kids have to create a hinaki, which was perfect because it was a part of my kaupapa at Kura. And because I'm one of the writers for the assessments, that's what I wrote. So if we're thinking about Pāngarau, first they have to look at the history of hinaki. So the first picture is a hinaki that Pania seen in Te Papa, and she's, because I was in a hui with her the week before, and she sent the photos to me of the hinaki that they had at Te Papa, in the undergrounds of Te Papa. Through the research that the akonga done, the hinaki of the old days were made out of vines. They were weaved together with harakeke, and they looked completely different to the hinaki that we have these days. The second picture is a picture that I gave to my kids that I created on Adobe Illustrator with how we could create our hinaki. So at that stage, I didn't know what the dimensions would be. I just chucked some dimensions on there and then gave them to the kids. And then they started creating the hinaki, which is on the right. Now, if we're thinking about the Pāngarau, the mathematics, because the standards, if we're thinking about the NCEA standards that are aligned to this, firstly, whakaaro tau. So the kids coming up with a budget on how much it's going to cost them to build a hinaki, and then comparing those costs between different places. So that was their kaupapa tau, which is Pāngarau 1.1. And then 1.4 for Pāngarau is ine me te hanga. So as they created the hinaki, they had to think about having the right size hole for the tuna to get through, but not be able to get out. They needed to account for how many tuna could fit into the hinaki, because the average size of tuna that we caught in Otaki, I think they were 70 centimeters long. So it was to enable as many tuna as we could get into the hinaki. So that was another mathematic thing that they had to solve. How many tuna they could get into the hinaki, how big the hinaki had to be, the size of the holes that the hinaki go through. And then we ended up building the hinaki on the right. So that hinaki, these are more testers. So my father is he's our fix-it man at school. He's our builder at school, and I sent him some plans and asked him to help the kids build the hinaki. he basically chucked my plans away and done it how he wanted to do it because he's built hinaki before, which is fine with me. It was just, but the kids have experienced building a hinaki, and the plan is next term they get to use the hinaki to see if they work. Apai. So hopefully you can see the Pāngarau and the maths in this first kaupapa. So there's measurement in there, there's algebra in there, there's number in there if we're thinking about the NCEA standards. Okay. The second kaupapa was on watercress. So this kaupapa actually started through one of our local groups, Ngā Hapu Otaki, where they approached us last year to see if we wanted to be a part of a kaupapa where we would put watercress pontoons into streams and then see if the streams became healthier after a certain time while the watercress pontoons were in there. So we put the pontoons in at the end of last term or midway through last term. And after reading how long the watercress should take to grow, it said watercress will grow in the next 6 weeks, ready for you to pick. This has taken us 3 months to go from the left picture to the right picture. So we didn't take into account the temperature and all those sort of things. But this is a statistical investigation for the kids where they are testing the pH levels, they're testing the nitrate levels and the phosphate levels of the streams where the hinaki is. So of the stream where the hinaki is, right next to the first pontoon here is a spring. So there's a spring under the water there, underground in the water. There's a spring underground, and so we thought that one would grow more than the rest. But what ended up happening in the second picture there, a whole lot of weed grew around it, and the watercress didn't get much of a chance to grow through. About 10 meters up the stream, we planted the last one, and that one's flourished. So this is a kaupapa that I am doing with my year 12 students. It covers a statistical inference paper. It's an experiment. Once they write their report, they can evaluate the report, and yeah, so those are the 3 standards. Also, so these aren't just Pāngarau standards. So there are also standards that align with Pūtaiao. There are standards in this that align with Hangarau, because this is a Hangarau take, the hinaki is a Hangarau take. There's tikanga ā-Iwi standards, there's geography standards, there's all these different types of kinds of standards that we've integrated into our kaupapa. Okay. That's not meant to pop up. So the yellow mark there, so the yellow line, that is, so my Kura is around here, and that's the stream that's behind us. Before the farms were built, the yellow part there, that's what Maringi-a-Wai was. So the word Maringi-a-Wai, it means that there were a whole lot of springs underneath, and when it flooded, when it rained, just a little bit of rain, that whole place just flooded. In the old days, there were tuna in there, there were pātiki in there, the koura in there, everything. So it was a food source for our tupuna. Over the years, obviously, so you can see the outline of the, that's how the stream is now. So thinking about this last term, I was trying to think about how we could, how my year 12s, how we could align the trigonometry paper to this. So the goal here, the measurements on there, I use Google Maps to do the measurements, and then they'll use trigonometry to find the area of the of Maringiawai, what the area was in the past. So that's the Pāngarau in this. And then the last one is the tuna kaupapa. This week we have just completed 2 of the assessments for this mahi. The first half of the year, my kids done a whole lot of eeling. They needed to understand why we were collecting the data. Why do we have to see if there's fungal patches on the eels? Why do we see if if the anal is red? All these different things to help with the data. So if we think about tuna are fascinating. Like you think about tuna when the tuna is ready to spawn, it migrates out to the Pacific Ocean around Tonga. The eggs are laid, and then it takes them 9 to 12 months to get back to Aotearoa, and the tuna that come back to Aotearoa, they go to exactly the same place that their mum was. The issue with tuna now is that they can get down the dams. So if you're thinking about Waikato, they can get down the dams, but they can't get back up. So that's why the tuna is in decline in Waikato right now, because they get stuck up there. We don't have that issue here. But we still, there are ways that can tell us, there are ways that tuna can tell us if the streams are clean. So if there are fungal patches all over a tuna, it means that they're not eating. And the food that they're eating isn't the right food. If there's a discoloration on it, the same type of thing. If a tuna has a bite mark, it means that the bigger tunas are trying to eat the smaller tunas because there's not enough other food for them to eat. And then a red anal means that the tuna eating sand, or they're eating snails, which they don't eat, and it's bad for their diet. So that was all the data that my students had to collect, and then the length and the weight of tuna. It's like my kids love, especially my boys love going eeling. So it was something that, and I love going eeling too. It was something that excited them. We would have 2 days where the kids one day where we set the hinaki, the next day we'd go out and collect the eels. One day we collected, I think it was like 60 tuna from 5 different streams, or 5 different parts of the same stream. So it was just to collect and click the data and chuck the tuna back. I asked my dad if he wanted any tuna, but he said, "Oh, I only want 10. I don't want 1." So I chucked them all back because he wasn't going to get 10. So this kaupapa is for my NCEA level 3 students. It's a bivariate data kaupapa. It is also the statistical inference kaupapa. And there is a part to it which we haven't covered yet on time series. So there's a saying that you shouldn't catch tuna in the months that don't have an R. So you shouldn't catch tuna in, what is it, May, June, July, and August. That's something that was passed down to my dad. That's something that was told to me. So when we went eeling in June, I says to my dad, "So what, you're saying there's not going to be any tuna in there?" He's like, "Oh, well, there might be, because it's a bit harder for our tuna to get back to the ocean because we have floodgates and stuff between the farms and the oceans." But the reason for that is that the tuna migrate in March, April, when there are big rains. And when it's cold, they usually hide away. They don't come out when it's cold. They only come out when it's warm. So it's setting a hinaki is different to going out and spearing tuna. I don't think you'd find many tuna if you were spearing them. So we collected the data. The kids have written, have compared the size or weight of tuna from one stream to the other stream. They've written their reports. A part of the reports is a whole lot of research. And that's the part that I think they enjoyed most. There's the mathematics is a part of it, but them talking to their parents about what they used to do when they were kids, or their grandparents, hearing the stories of how they made hinaki, about all those different things, was the thing that they enjoyed most. But there are a whole lot of Pāngarau in this. I just seen there's 2 minutes to wrap up. I've spoken for ages. The last picture there. So when I was a kid, we used to get crawlies in our streams all the time. We lived in a house where we had a creek at the back, and we would be in our creek getting crawlies every week, cooking crawlies every week. This is the first time I've seen a crawlie in a stream in Otaki for the past 35 years. So what it says is that the environment, the creeks and stuff are healthier. And this crawlie was found on a farm, so that's probably, like in the past, next to streams on farms, they didn't have gates, no fences. Now they have to have fences, so everything's coming back to life. Anyway, hopefully you can see all the Pāngarau, and I'll pass it back to Pania.
I'm going to pass it to you, Kerry.
Oh, look, absolutely fascinating, the two of you. Thank you both so much for sharing your wisdom. And really, I know for me that you just, both of you just reminded me so much of that, the strength in student-centered learning, and the strength in actually looking and drawing our learning experiences out of our environments, out of where our students come from and the things that matter to them. So thank you both so much. And honestly, that was, I mean, hopefully, I know that I'm probably speaking for everyone, that was really, really, really inspiring. So thank you. Thank you.